Don't want to waste your time, we are going to make this. As you see, it's a destruction tutorial. We're going to destruct boxes and different objects. So let's start from scratch, because here we have complete scene. Here we have an empty scene. It is a 2D scene, but this tutorial is suitable for 3D as well. Of course, it requires Unity for with 2D options to make game. So basically, we have scene with setup colliders and some background like this. We want to destroy different objects. First of all, let's try to destroy box. We have imported box. Now it's quite not set up it, so it's not react with physics. It's simply steel. So let's add some rigid body and colliders for it. Component. Let's add some realistic mass. For example, about 30 kilograms, or maybe 60. Yeah. Gravity scale is okay, and everything is well. Let's see how it works. Yeah, it's okay. So we want to destroy a box. We have different options like procedurally split into pieces, but this technique works very good for something that made from one piece of material, for example from wood or stone. But for human-made objects like boxes, it is quite non-realistic to split procedurally. That's why we use prep splitted objects and then just apply physics that reacts on instructions. So first we need to split this box into pieces before we use Photoshop for this technique. Let's open it. Yeah. The idea is to split sprite into pieces that can be destructed in the real way. For example, this wood, of course, can be splitted like this. Then we will add it into additional layer. In fact, I'm not a big pro of Photoshop, and I think that designers can do it much better. So, like this, probably. It's quite boring thing, but at the end we have a lot of layers of our splitted objects. I will see how it looks like. Let's close it. Don't want to waste your time again. So let's take a look at already splitted object. All assets you can find in a complete version of tutorial, so for start you don't need to split it yours by yourself. Here it is. Here you can see that box is split into many pieces, and every piece is put in a separate level. Why do we need this? Next we are going to automate and create batch scripts, export layers to files. We will have a lot of different pieces of the box, so that pieces we can show when we destroy a box. Let's create folder in the desktop. Broken box. Yeah, like this. Main option is not to trim layers, because we use same pivot if we have a lot of pieces, we don't want to make it to move it by ourselves. It's take a lot of time. Of course, it's not very good for optimization, because we store a lot of unused texture data, but for tutorials it's quite okay, I think. Make sure that it's PNG, transparent, and not trimmed. Okay, run. Wait for a while. You can see like Photoshop is processing every layer and making separate things. It's not very fast. Action effect. You can drink tea for a while. Seems like every layer is hidden and then saved. Damn, it's so slowly. But anyway, I think it is much more convenient and simpler than exporting each layer by itself, by hands. Probably I can stop this because I have already exported files and I can simply show how it looks like. So I try to stop this. I don't know is it possible or not. Please stop. Yeah. Thanks. Stop, please. Come on. Probably I should open Task Manager for this. And destroy Photoshop. It's already make some objects, and you can see how it looks like. Each part is stored with a lot of empty space that used for pivot, and it should look like this. Let's destroy. You will have something like this already made by me. I have a second monitor on which I have different data just to keep this place clear. So please preview, view, our dragons. Here it is. All of them is here. Windows Meta. So let's simply drag this folder into sprites. It's done. Dun dun. Let's put the object into 0. Here. Make sure that box at scale pixels to unit to 100. 100. So if I put this one, probably can hide and see that part is in correct place. That's very important because we have a lot of different parts to move. If we select a lot of things and try to put into scene, we will create an animation. This is a built-in function of Unity, so it's probably an annoying thing, but you should do it by your hands, like this, and this, and this, and this, and this. This technique is used in many games like Flatout, or oh, I made some child. So yeah, like this. Come on, Jesus Christ! It's 7, 8. It's not a very convenient way, but I have no idea how to make other way. 9, 10, 11, 12. You can see how box is filled step by step. 13. I know it's quite boring now, but next week we're gonna destroy everything. Looks much cooler. 15, 16, come on, 17, 18, 19, 20, 21, 22, 23, 25. Be sure that there is no nesting like this, and simply move it into a root. Okay, here we have split box into pieces. Next, what we're going to do is to attach them to a root not splitted object called box. We're going to select all of them, but first of all we can test all of these pieces. I think we're going to add them a collider and a rigid body. Components rigid body, be sure it's a rigid body 2D. Mass. I think it's about 50 kilograms split into. Oh, I don't select all of them. Be sure that you select all of these pieces. Into 26 parts, I think 2 kilograms into each part is very suitable. Gravity scale, everything's okay. Add component collider. We need polygon collider. Yeah, something like this. You can see that it's covered well. If we can hit play, we can see some results, I think. But there is a ground, yeah. There is a ground. Let's put it above the ground to see how it looks like. Like this. You can see that object is splitted and looks destroyed. Then all of these pieces please attach to the root object called box and make active box. Oh, wait for a while, reset this position. Yeah. Please make sure that all of them is perfectly matching place. Like this. And of course, make this child objects invisible, because when box is okay, not broken, it looks okay, and reacts like one big assembled object. Make sure that you save the scene and see what we have here. Something like this. Next step is to know when we're going to disable this object and show pieces. Physics help us to understand how it works. In real physics, there is a called delta impulse that used for destructions and why objects is actually destructed. In Unity, there is no options to get the impulse at the moment of collision, because on collision method returns velocity 0, and that can be used in calculation of destruction. That's why we're going to create an interface called iPhysics that return impulse of physics-based objects. So in the script folders, create a script C# called iPhysics. Physics, and opened. If you're familiar with C#, you should probably know how interfaces works. So let's create one of them. Wait for a while. Okay. We will rename class into interface. It's not inherited from mono behavior, so remove it. And all of these methods. We are going to return impulse of an object and leave just getter, because this property is set by the physics engine. We can't change it by ourselves, I think. But in your architecture it probably can be changed. So leave it that way. It is quite okay. Then we're going to create base class that supports iPhysics interface that's used for non-destructible objects, but objects can store this impulse. Let's call this indestructible and create new script. Indestructible. Indestructible. I hope it's indestructible. There is no error. Yeah. This class will derive from mono behavior and support already iPhysics interface. iPhysics, yes. There is no update and start function in this class, so create just protected property for velocity. If you use this for 3D, of course you can simply change this for vector free and rigid body. That works with 3D objects. Just for simplifying tutorial, I choose 2D rendering. But the logic is absolutely the same. Visual wait, fix it, update. By 2D velocity region iPhysics implementation and region public virtual vector 2. Here we implement impulse property, impulse, and this getter. Of course, this tutorial is not for beginners, that people who not using object-oriented programming or interfacing in C#. So I recommended to learn this, because for even middle-sized objects, you cannot write them without understanding of object-oriented programming. So return velocity multiplied on the rigid body to the mass. That's the definition of the impulse used in physics. That's way we will get an impulse of an object in the moment of collision. And of course we store this velocity in the fixed update. Why not in the update? Because physics in Unity works in the separate time called fixed, and there is no sense to assign velocity into update cycle, because it changed only in fixed update. Okay, let's save it. Let's see, is it okay or not? Yeah, it's okay. So we can add this script into every pieces of the box, because they are not destructible. Of course you can make this destructible for any further destruction of the pieces, but leave it just as is. Next we are going to create a script or class that calculate delta impulse and on this data destruct our box. So let's create script called destructible base. Of course you can use them as a base class for any other objects. Let's create C# scripts destructible base. It's a very good idea to store everything into folders, to make everything organized. Destructible base will inherit from the indestructible. We need couple of properties that used for destruction of an object. In physics we need some value that will indicate on the speed and mass that required to destroy this object. So let's call it destruction impulse. And the eigenvalue about, I don't know, about 50. This is a mass multiplied into meters per second. We don't need a start function, so remove it. And update, we also do not need update. All that we need is on collision 2D methods. So protected virtual void on collision enter 2D collision 2D collision. Here it is. Let's store our impulse in the moment of collision, called my impulse, obviously, and initialize other impulse with vector to 0. Now we're gonna go through all points of collision and calculate all impulses for each contact point to DCP in collision contacts. iPhysics. Let's get our iPhysics interface from every object. Collider, get component, type of iPhysics. That's why it is suitable to use an interface, because very not similar objects have implemented iPhysics, and we can get just iPhysics, not any specific class. But anyway, if there is no iPhysics interface on the object, we can use other impulse for other formula. Here we take add impulse of the object to the other impulse, else let's check there is no collider applied. Let's store result impulse. In fact, this never works, so equal to, we can simply remove this line, I think. Never works here. Result impulse called my impulse. This other impulse. Let's calculate delta impulse. Like this. Magnitude. With magnitude for value that indicates where we're going to destruct our object. Bigger than destruction. How we call destruction impulse? Destruction. That's way. We're probably do basically destruction. Destroy self here. In destroy self we are going to hide object, make all these parents, transform parented to a root scene, so every piece gonna move by itself and will inherit all the physics, derive it from the interaction. Let's create an enumerator. Destroy self, basically. I think we are out of scope now. We're gonna wait till a fixed update will come, so all this collision calculation will be done, and we use this data of the Agea physics engine to assign it to our pieces, because we don't need to and don't want to calculate huge quotients of that will be used for physics simulation. Yield return new weights for fixed update. Here it is. List. Because we are using list, we're gonna use system collections generic. Yeah. Transform childs. New list. Transform. Here it is. Reach transform. I think I can make it much faster. Childs. Why it's not okay? For each transform. I have no idea why it's not working now, but let's check by compiling this script. Unexpected symbol. Oh, I forgot comma. Reach transform t in childs. Here we assign parent to null. Make came object set active true. Rigid body. It is a very important part. We are assigning velocity that used in the simulation. (2D) oh no, random inside the unity circle. Yeah, that's no. Rigid body 2D body 2D. Of course this way. Velocity normalized. We also assign angular velocity. That object will have during a collision. And then simply destroy our root object that's visible here. Destroy game object. Let's see how it looks and how to set up these things. Let's assign him this script table base into object. Here it is. Let's preview. Here you can see that object is destroyed and everything is broken. If we will increase an destruction impulse into something like this, it will not destroy. and of course you can duplicate objects. Where it is? Where there is a scale. Simply duplicate. Make a couple of boxes. Make them destroy. Let's play. Of course, I'm a bit laggy now because of a lot of objects that simulate in physics. Oh, but looks very cool, I think. If we make destruction impulse a little bigger, I think 100. We will get the same way. Let's make it wait for a while. 200. We will get something like this. Some objects is destroyed and some is quite okay. So it's on your own to set up this, how this actually works by assigning this value. So your designer should tune this value as well. But I also recommend to make a physics material that used for simulation. Let's create physics material called physics 2D material called wood. It will have some bounds that used for simulation, so let's add about 15 value. I forgot to add it into a box. Let's make a prefab that we will controlling all the boxes. I think it's much faster. Like this. Yeah, here it is. Let's add physics material into this option. Hit apply. And see how it works. Here you can see that box is moving a little bit. We have little bounds that it's more realistic as for wood. And also for every piece of the box we should add this material. Apply, apply. Yeah. And let's... Here we can have a little fun by multiplying these objects and play with them a little. Make it bigger, mass bigger, size different, rotation, like this. Of course we should add mass according to the size, but not every one is broken. Let's make this one with the mass of 200 kilograms. I think now it's gonna broke into pieces. Yeah, it was predictable. For a better simulation and make this more realistic, I recommend to set up each part separately, because, for example, this part, let's make it visible, and this part have different mass. Probably this one will have 2 kilograms and this one will have this half of the kilograms, like 1. So please set up each part separately, and we'll get more physics and realistic results. This is part of Anoxemia tutorials that using upcoming game Anoxemia. Then you can vote on Steam. Please check it here, vote, subscribe, and leave your comments, please. All the assets you can find in the on my blog with a mirror link, so you can download start scene and complete scene for your own experimentations and make destructions. Thanks for watching, bye.